Hello everyone, I am Devi, Assistant Professor in Department of Mechanical in Akshaya College of Engineering and Technology. Today we are going to see the topic from Fluid Mechanics and Machinery. From Fluid Mechanics and Machineries, we are going to see the topic of fluid properties and flow characteristics. Properties of fluid. Here, every fluid has a set of characteristics that can be used to define its physical state. These features are referred to as fluid properties. In fluid properties, it is categorized into two: intensive properties and extensive properties. In intensive properties, it is independent on mass. In extensive properties, it is dependent on mass. Here, the sum of the fluid properties are density, specific weight, specific gravity, viscosity, specific volume, vapor pressure. Properties of fluids: specific mass, mass density; specific weight, weight density; specific volume, specific gravity, viscosity; compressibility and bulk modulus; vapor pressure; surface tension and capillarity. Specific mass or mass density, rho. The mass that a fluid has per unit volume is known as mass density. Mass density rho is equal to mass by volume. Its unit is kilogram per meter cube. Thus, density is directly proportional to the number of molecules in unit volume of liquid. Here is given us some example: density and states of matter. Here we have given a three bowls. It's given gas, liquid and solid. In gas it has low density. In solid it has high density. Specific weight or weight density, W. Weight density of a fluid is the weight it possesses per unit volume, that is weight of the fluid by volume of the fluid. Its unit is Newton per meter cube. Specific volume. It is defined as the volume of the fluid occupied by a unit mass, that is volume of a fluid by mass of the fluid. Its unit is meter cube by kilogram. Here, specific volume is reciprocal of mass density and it is applied to compressible fluid, that is gases. In next, specific gravity. It is the ratio of density of a substance to the density of some standard substance at a specified temperature, that is mass density or weight density of a fluid by mass density or weight density of a standard fluid. The substance in specific gravity is a dimensionless property. In specific gravity is less than 1 or lighter than water, thus float on water, and substances with specific gravity more than 1 or heavier than water, thus sink into water. Next, viscosity. Experimental data shows the viscosity velocity of any fluid flowing over a solid surface is not constant across all cross sections. Here in water, it has a low viscosity. If for example, we can take in castor oil or honey, it has a high viscosity. In another diagram, we have shown the velocity of a fluid is not constant or across the cross sections. Next, it is defined as the property of a fluid which offers resistance to the movement of one layer of the fluid over another adjacent layer of fluid. The viscosity aspect of velocity ratio V difference indicates the existence of some resistance to flow due to friction between the fluid layer and the solid surface and between adjacent layers of fluid itself. And in this, resistance to flow because of internal friction is known as viscous resistance, and the property which enables the fluid to offer resistance to relative motion between adjacent layers is called viscosity. Viscosity have a Newton's law of viscosity. Here it's given at two examples, whereas boundary plate, it is a 2D and stationary, whereas a dimension and velocity, shear stress and gradient to dou u by dou y, where it is tau is equal to mu dou u by dou y, where mu is viscosity, tau is equal to shear stress, that is force by area, du by dy is equal to rate of shear deformation. We have types of viscosity. There are two types of viscosities, that is dynamic or absolute viscosity notated by mu, kinematic viscosity V. For absolute viscosity, mu is equal to shear stress by du by dy. In kinematic viscosity, V is equal to dynamic viscosity by mass density, that is mu by rho. Its unit of viscosity for dynamic viscosity is Newton second per meter square, that is 1 poise is equal to 1 by 10 Newton second by meter square. Kinematic viscosity unit is equal to meter square by second. That here it's given in stroke. 1 stroke is equal to 10 to the power of minus 4 meter square by seconds. Here given a vapor pressure and cavitational examples. Had taken a water, bubbles cannot form since the vapor pressure is less than the atmospheric pressure. In boiling, bubbles can form, and since the vapor pressure can overcome atmospheric pressure. Here, evaporation and closed vacuum bowl, evaporation which has reached the equilibrium with the liquid surface. Next, vapor pressure. Thus, the pressure exerted on the liquid surface by the liquid vapor is called vapor pressure. A liquid boils when the vapor pressure equals the external pressure. And cavitation. Cavitation is nothing but occurs when the fluid pressure is reduced to the local vapor pressure and boiling occurs. Vapor bubbles from the liquid grows and collapse, producing shock waves and noise and dynamic efforts. Given cavitational typically occurs at location where the velocity is high. Here I have given us some examples for cavitation. It's given a vapor bubbles where it is fluid Next, compressibility and bulk modulus. The compressibility of a fluid is ability to change its volume under pressure. Also, relative change of volume per unit pressure is known as coefficient of compressibility. It is compressible and incompressible flows has given example, incompressible fluid and compressible fluid. In incompressible fluid flows assume that fluid have constant density, while in compressible fluid flows density is variable and becomes function of temperature and pressure. And bulk modulus, the compressibility of a fluid is expressed by its bulk modulus of elasticity K, which is the inverse of coefficient of compressibility, whereas K is equal to dB by minus dV by V. Next one is surface tension. Concept of cohesion and adhesion. The property of the liquid surface film to exert a tension force is called as surface tension sigma. In other words, it is the force required to maintain the unit length of film in equilibrium condition, where unit of surface tension is Newton per m meter. Here I have given example polar or charged object. Here adhesion and adhesion is in the corners and the cohesion in the mid of the objects, how the molecules are reacting. Another example is water substance is kept in the bowl, whereas in air in the surface and the liquid, how the cohesive forces to neighboring molecules, missing cohesive forces to neighboring molecules. Here force is directed at the interior of the medium, here missing water molecules. The next, surface tension. In case 1, pressure inside the liquid droplet. How it is, the pressure is going. Pressure inside the liquid drop, surface tension of the liquid and diameter of the droplet. The pressure is equal to 4 sigma by D. Capillarity, the phenomena of rise or fall of a liquid surface related to the adjacent general level of liquid surface is known as capillarity. Here I have given an example for capillary action in water and also in mercury. Adhesion is greater than cohesion, and in mercury, adhesion is less than cohesion. These are the examples for the capillarity. The rise of the liquid is known as capillarity rise. The lowering of liquid surface is known as capillary dispersion. Thank you.